Cool, so what I want to talk about is ARM, because ARM is cool and ARM is everywhere. So I brought in a bunch of ARM devices. This right here, actually this isn't ARM, this is Atom, but a lot of other devices like this are ARM, so I brought it in as an example. But this is a Google TV. Apple TV runs ARM. This particular Google TV runs Atom. This is a router. This doesn't run ARM, but it runs MIPS, which is very similar. This is a BeagleBoard XM, a Gumsticks, the processor on here. Well, I don't want to take it off, but it's just that thing that's the size of a stick of gum. All right, and this is a Panda board, which is the successor to the BeagleBoard. And I think that's kind of all the gadgetry I've got with me. Except that iPhone is ARM, and the iPad underneath it is ARM, and every phone in your pocket is ARM, and that tablet you've got in your hand is ARM, and so ARM is everywhere. I believe there are more ARM CPUs than there are Intel CPUs currently because of all the little devices. So, does everybody know what this stuff means? All right, so instruction set architecture is like what the processor can do. Like it can multiply, it can divide, it can decode something. And then RISC means reduced instruction set computer. So I don't remember the particulars, but they just cut everything in half. So if the computer can multiply and divide, then then a RISC computer only does multiplication, because by multiplication you can do division. So kind of things like that. It cuts a lot of shortcuts so that it does fewer things. Instead of anding and ORing and XORing and all that, and NANDing, it just picks the simplest operations, and then it focuses just on those. And ARM is licensed by ARM Holdings, so that's why TI, Marvell, Broadcom, Samsung, Apple, like all these other companies use ARM, because there's not an official ARM manufacturer, it's all licensed. So architectures, just to give a brief overview in case you're not familiar, x86 is what was developed by Intel. That is what's inside all of your laptops and most of your home computers. x64 is an extension of x86, which is the 64-bit stuff. That's actually what all your laptops and desktops today are running. That was developed by AMD, and so Intel actually licenses that technology from AMD, because AMD had it first. Well, Intel has a titanium, they've got another architecture that's 64-bit, but it didn't catch on because it wasn't backwards compatible like the x64 is. PowerPC, that's what all your game stations are on. It's a much more powerful processor, and it has more registers in it, so it can do more things at a time. Then FPGAs and ASICs, not really my thing, but that's what your stuff like your Nintendo clones and whatnot are made out of. Probably not ASICs, because the Nintendo clones are generally cheap hobby computers, and ASICs are more expensive. Anybody have like a brief definition of ASIC, what that is?
Circuit designs for your specific application.
So like
custom circuit.
So basically, if I understand correctly, you prototype with an FPGA, and then if you want it hardcore, you then spend $50,000 to get it turned into an ASIC. Yeah. Okay. or a couple million, yeah, whatever. Okay. So MIPS and ARM, I think branched off of the same architecture. If I remember correctly, you can read it on Wikipedia, but like the company split up, and one part of the company took MIPS and developed it further in generations, and then the other one got ARM. And most ARM devices come with a DSP, and some of them have an SSL accelerator, although you've got to have like some sort of NDA with the vendors to get information about it. Because things like your phone, ARM is really simple. So if you want to do business logic, if, else, then, while, loop, all that stuff, ARM's great for. Does it really well. But when it gets into algorithms like compression, decompression, encryption, decryption, anything where you start throwing a lot of math around and it's not just business decisions, that's where ARM just sucks terribly. So compiling on ARM is wretched. And so you have a DSP, that's why you're able to have your iPhone that can play media. It doesn't need a heat sink, and it does it really efficiently because it's got a DSP with some sort of algorithm loaded into that DSP that you hand it MPEG data and it knows exactly what to do with each frame, and it does it really fast. So on the business logic side, you've got ARM, and then on the algorithm logic side, you have DSP, and then on the cryptography side, you might have another chip as well, and those go in. So like every phone you have is going to be dual core basically, and then some of them, they say dual core, they mean ARM plus DSP or plus cryptography or whatever, but then some of them mean there's actually 2 ARM cores plus the DSP in addition, so it's actually like tri-core. So that's in your phones, your TV, your set-top boxes, your handheld game consoles, the Nintendo DS, stuff like that. And the reason you want ARM is because it's low power, it's low heat, and it's small. So I want you to take a look at this. Anybody have a phone handy I can just hold up for comparison real quick? Just
old school.
Okay, well this one's a little bit bigger, or this is a little bit bigger in this case, but you know, iPhone, this kind of phone. So there's the dimensions on this. This has almost all the same capabilities that this does, except it doesn't have a cell phone antenna. Plop a hard drive on it, you know, and then it's only this big, right? So you can have a full laptop system or tablet that you can build yourself and just kind of, you know, lay these things next to each other, and it's super thin. Right? So the smallness is nice. Also, it's low power. So what I could do is I could take this cable and you know, that normally would have gone to something like this, but I'm just ripping stuff apart here because I want to prototype an iPod. I could just plug this right into my laptop and then hook it up to the power connectors on here and power this thing up. It's 5 volts, right? All of these devices are 5 volts. So for a demonstration of that, I've got a power pack here. It's meant to charge an iPhone. I can plug it into this guy with this USB cable that I've hacked from a printer cable and a Radio Shack head for a power adapter. Plug this guy in, and bam, powered. So, you know, maybe a little bit large for a prototype iPod, but you know, and you can buy the components inside of this thing and hack it yourself and maybe make it even a little smarter. At sites like Instructables, they've got design plans for this, where you know it has the chip that you need to buy for a charger and the way you need to etch the board and stuff like that. So can be really cool, really small. Notice there's no heatsink on here. Like I said before, there's no heatsink on any of these because it's that low power. And if you want to get started doing stuff with ARM, there's hardware, software, and toolchain. So hardware means you want to pick something like the Beagle board or the Panda board or Gumsticks or Snowball or Raspberry Pi. I don't know how I failed to mention that one already. But so you pick something like that, and then you kind of want to pick your hardware and software in combination, because the development in ARM right now is really ad hoc and fast-paced, and when you want to like make devices, you're splicing cords and getting out your soldering iron, and so it's not quite as structured and sit down as it is with, you know, your normal Linux box that you get. So you want to pair the hardware and software, and I'll get to that in a minute. And then the tool chain is like what you want to use on your computer if you need to do any compiling, which I recommend you don't do if you can avoid it. I'll get to that in a minute. But it's things you may have heard of. Shiva plug I didn't mention before either, but I think that was the first ARM device I'd ever heard of. I think it's ARM, it might be MIPS. But so Ubuntu is like the leader in ARM right now from the hobbyist perspective of like non-expert getting into the field. Ubuntu has spun off a foundation called Linaro, and or they I don't know. There used to be, I'm not even going to go there. I don't exactly understand what the relationship is between them, but they're tied together, and Linaro is like kind of funded by Ubuntu, kind of has some Ubuntu employees, and their focus is ARM. So they compile everything natively for ARM, on ARM. So I think this is kind of like the most stable. And then this is probably more popular right now, is Open Embedded, because it's been around longer. It's based on Gentoo. It's like a branch off of Gentoo ARM or something, and probably somebody would shoot me for saying that because they've rewritten it, and you know, so I don't think it's really based on Gentoo anymore, but at some point it had some underpinnings there. And this one is just like really complicated. It takes like 30 gigs to install, but then you get all your, you know, your compile options. Like you compile the whole system specifically for a Cortex A9 dual core with, you know, whatever technology that you've got. So if you want to get more down to the metal, that's an option, but I would recommend Gentoo for somebody learning Linux. I would not recommend Open Embedded for somebody learning ARM. I'd recommend going this route first, get the overhead out of the way, and then go that route if that's what you're up for. And then the tool chain, the Ubuntu-Linaro combination is really great because they're very tightly together. Open Embedded is not so great because they're working for everybody. So any distribution that you're going to run, you know, Open Embedded, it'll work on it somehow, but they don't have such a nice tight focus as you get with one of the Ubuntu derivatives. And then there's other ones like Code Sorcery, which TI and I think Marvel, maybe a couple others use. Is just like there's a company that they developed a tool chain for ARM, but I think this is losing ground. Like that might be what, if you had a large vendor, they might recommend this to you. But I think in the community, you're going to see a lot more of this and a lot more of this. And so toolchain is like GCC and all that jazz. Any questions so far? I'm going really fast and I'm not asking for questions. So if anybody has a question right now, raise your hand. Confused about anything, come on. Somebody's got to not be following me entirely. All right, well, forever hold your peace. So these things, there's your host computer and your target computer. Your target is ARM and your host is your x86 or x64 box. And cross-compiling sucks. So if at all you can avoid it, you know, because the complaint is, oh, it takes 40 minutes to compile Python and I'm gonna die. And it's true, it sucks really bad to compile it on ARM. But the flip side is, oh, I spent 7 months trying to figure out how to compile from my Ubuntu box to my ARM box, but now I have compiles that go in 3 minutes instead of 40. So maybe not 7 months, but more in the order of 3 to 6 weeks kind of thing. So I think if somebody tells you that you should cross-compile it, I tell you shouldn't, because it's going to take longer, you're going to do more debugging, it's going to be more difficult, and then the Linaro strategy is that they've already cross-compiled, or not cross-compiled, already native compiled most of the stuff you're going to use themselves, so it's a little bit more reliable. Back when I first played with Open Embedded, I had a headache with it. And then development. Your standard development tools for developing on your target are going to be like C and Python. Really mature, going to work well. Other things like Ruby with Linaro, it's probably going to go fine. With maybe Open Embedded, not quite as well. I would say these are probably the most mature. But then new guys on the block. Google is very interested in promoting what they're doing. So they've got Go running on ARM so that they can put it on the phones. And they got V8 running on ARM, so it's already on all your phones, right, if you've got Android. And so Node.js also works on ARM fairly well. There's some gotchas. It's, as you know, it's new. It's not extremely mature. Neither of these are extremely mature. But if you want a fun programming environment, these are two choices that are pretty easy to get set up on ARM nowadays because of the Google backing. And then getting started, there's a couple things that are really different. There's no BIOS on ARM. Everybody knows what BIOS is, right? So like you boot up your computer and you get the black screen and you put your floppy in and then you install Windows 3.1 and it's really easy. Well, with ARM it's a little bit different because initially, if you don't have your SD card in, you've just got something in the CPU that says that it's either going to be looking to some onboard NAND, which is like flash memory, like what you have in a USB drive, or it's going to look directly to the SD card to figure out like how it's supposed to load. And so you kind of have to start from something that's already working before you can go in and tweak it. So you have to like download an SD card image, DD it onto the SD card, and then after that you could maybe put it onto the NAND that's built in with the CPU stack thing they got on. Because like there's the CPU, the memory, the DSP, and then maybe a couple other gizmos are all like in one chip, and I forget what they call that, like computer on module or something? System on chip. System on chip. Okay, computer on module is this type of board. System on chip is that they pack so much stuff into a single chip. Yeah. So yeah, the boot process is a little bit different. It's a little more hardcore, and then you don't have your regular expansions except for USB, and then even USB, like a lot of stuff is serial. Like for example, I have here this little GPS chip I bought off of eBay, and a USB to serial TTL converter, and then some now broken wires that go between it. So I actually was playing around with this. I could never get a GPS lock. I think it's just because it's a cheap chip from China, but well, I guess all the chips are from China, even the expensive ones, so that doesn't stand up. Anyway, but I at least was able to get the readout on it and see what like GPS data looked like, and I actually opened this one up with Node.js, because so to give some background that I didn't give, like my life's ambition is to create a media server that you stick in your home that would be like half the size of this, like the Apple TV size kind of thing, and that you just plug it in, connect it to the cloud. There's my plug for the cloud. And then be able to access it anywhere, like school, work, whatever. Because the thing that bugs the crap out of me is there's all these cloud services coming up, and they're like, you can have 20 gigs of free space, and then you can pay for like 50 gigs of space. What does that do you for? I mean, does anybody watch movies in here? You got those on your computer? Like, 20 gigs is nothing. Putting your media on 50 gigabyte cloud storage is absolutely useless. And there's all this licensing stuff and everything. So like, that's my real big thing that I'm working on, is trying to figure out like, how do I take a terabyte hard drive and this box and create something where I can just have it be small and beautiful and do all that cool stuff, and then like be able to track where you are. I mean, basically, I think the idea of prototyping an iPod is just way cool, and the idea of something that's a little more open and more fun than an iPod is way cool. But back to this thing. So GPIOs are these little like one wire things. Let me see if I can. So you guys see all the holes in this board? So this is how you hook up like an extra SD card or like an extra battery or a camera. They go through, you just solder it on there. And GPIOs are really common. It's just a single wire that from the Linux kernel you can go into like /dev/GPIO/ GPIO_12 or something like that. And you can cat 1 or 0 into it as just a single bit value. So it's bit banging. If you actually want to send data across, you have to write a driver and all that. But for just bit banging, you can take something like put a little LED in here, and then turn the thing on, turn it off just by catting 1 and 0 into /dev/GPIO something or other. And then I2C is similar, but it's a little more hardcore because it actually has a protocol with it. It's not just on and off. And then USB and USB serial you're kind of familiar with, and I don't understand the protocols behind them that well. Anyway, it's not 86, so slow compile times. If you're trying to do algorithmic stuff without a DSP, it's wretched, it's going to suck your battery. And then if you can somehow get it, SSL acceleration chips are good. I don't really know anything about them other than they exist.
What's the floating point story? Any floating point at all, or?
Yeah, I think you get floating point. Let's see, VFP, the things that come to mind, like when I've run compile flags, I've seen like VFP and like eVFP, and it's like virtual floating point versus fixed floating point versus something else. And there's a couple different sub-architectures for ARM. One's called Thumb, and that's what the Nintendo DS, or maybe the previous generation of Nintendo ran on. But that's only 16-bit, and the whole math thing, I think it just depends on the chip, but I'm pretty sure the newer ones have that. I'm not an architect expert by any means, but and then more fun. So like I was saying, ad hoc gadgetry. You know, you put in a little LED, you catch something, you've got a light that turns on and off. You could set it up to turn a red light on when you get a Twitter feed. You know, that's what Android does, right? And it's the same thing. They're just opening up a GPIO and being like 1, and then the light comes on, right? Power it via USB. You can put it in your pocket, and these things. Some of these you can actually get the schematics online. So if you got a friend that does hardware, or you do hardware, you can open up the schematics. And if you go down to the maker meeting at the Transistor here in Utah, down in Provo, the guys there, they can help you out with that, like figure out how to do all that fancy stuff. But you can totally break this board apart and design your own board that's way smaller if that's the kind of thing you're into, or way bigger, have more stuff on it. So now, if there is any time, which there's only a little bit, what I want to do here is put some of this stuff together. So the USB drive idea didn't work out, but I kind of want to go through the process, taking this Panda board right here and show you a simple process by which we can get it to be an MP3 player. Sound good? Okay. So first of all, any questions? Or you can just continually ask me questions or talk about stuff.
So with the differences on the boards you've used, do any of them also support the SPI protocol that you're aware of? The
what?
SPI?
Oh, yeah. So I failed to mention that, but SPI is another thing. And SPI, I2C, GPIO, they're all kind of these like 1, 2, 3 wire protocols where you set a line. I think on SPI you set a line to open it, and then you set the other line to send the data, and then you unset the line and it closes.
You have a clock, so you have a master, a slave, and it's a bidirectional. So as you push, you always get one back.
Okay. Okay, so it's not, the line you are setting on is okay, you're clocking it. Yeah, so, yeah, most of them have that. And then you can actually, like from the Linux kernel in user space, with a lot of them, you can just cat into something like some GPIO, and you can tell it to switch what the function of something is. So you could have like GPIO 16, 17, 18, and right now they're being used for LEDs. Well, then you could like cat into GPIO to 225, 1, and then that will switch the functionality of 15, 16, 17 from GPIO to SPI. And this is what I want to bring up if I can figure out where my mouse went. Does anybody see my mouse? Oh, there it is. Cool. So let's see if we can find this stuff. Hopefully this is it. So all these sites have something like this where it just gives you the basics, and then normally there's going to be some place where you can download a schematic, and that'll give you information on how the GPIOs and SPI and I2C and MMC and all that. Was it right here? What?
Down one.
Right here? Okay, cool. And then the chips that most of these devices are running are either Broadcom, Marvel, or TI. And I think everything I've got here is TI. The Raspberry, I believe, is Broadcom. Anybody know?
It is Broadcom.
Yeah. So if you are the kind of person that knows what the heck this means, more power to you. And I just wanted to show that it's available. And if you're the kind of person that doesn't know what this means, it's still very helpful because like on the TI website, you can get this like bajillion thousand page manual because they couldn't figure out how to cut it into sections that were relevant. They just, the whole thing, everything. It's all in one like 80 megabyte PDF. And it'll tell you how you can switch something from being like a GPIO that you can use with LED to being like MMC. Because if you get, like, let's say you just have a broken card reader laying around, right? And you jack this out of it, you just unsolder it. Well, you can look online and you can find in the manual what you need to do to turn some of those GPIOs into MMC, and then you just like, solder the 8 wires that you need to in there. In whatever place they need to go, and now you've built yourself a card reader. So these schematics are really helpful if you're pairing the two together, like the OMAP chip or the Broadcom chip manual with this, because they'll be the same reference. I mean, it's really hard to see on here, but it gives, say like GPIO / MMC or whatever, and then you can say, oh well, that's where that pin is, so you can start the fun that way. This Panda board comes with a validation image, which I think is unique. Oh, and also this is really cool. Okay, this thing's got 1 gig of RAM, dual core 1 gigahertz ARM processors, and a DSP. This is like the best bang for your buck outside of Raspberry Pi. It's $174, and you can get it from a couple different manufacturers. I found mine through something called DigiKey. I don't know if anybody's heard of that. I'd never heard of it before, but that's what the site directed me to. Like these other ones, they're not quite so powerful. This is like 256 megs of RAM, and I think it's a 500 or 600 megahertz processor, and it's actually more expensive. But Gumsticks is nice because they have lots of board designs. Their core computer on module is one thing, and then like they have different boards for. Oh, let me show you this. This is way cool. If I have it, yeah, I do. Cool. So same computer. There's the Gumsticks on it, but this is something you could build, a nice Android phone type thing out of. So this screen here, as you can see, this is a Saturday project that never happened. I was going to put Android on this. But this is the same screen that goes on the, the commercial with the spider, and like the guy slams his shoe on the phone and starts, it's like, no? Okay, y'all don't watch TV, you just program, that's great. But anyway, so this is that really cool high-res screen. It's the same one. I think it is. Like LG and Samsung both offered it. I think they might have just switched to LG now. But anyway, so you can get touch screens and like all sorts of gadgetry, and it's just really awesome. But back to what I was saying. So there's a validation image for this thing, and what that does, no other board that I've seen has this. It goes through and it tests all the stuff on the board. So you can plug it in to some speakers, which I was going to show this really cool thing, and maybe I still will, because this isn't powered on yet, so it makes that difficult to show this. Anyway, you can plug this into speakers, HDMI, DVI, like all the things, and run the validation image, and when it boots up, it gives you like a loud lets you know the speakers are working, and then the screen starts flashing and doing different colors, and the HDMI is working. And then you have to stick a USB drive in, and it just like writes a few bits out and then writes them back and then tells you that's working. So, because like with these things, there's like tons of people that get really upset because they get a board and then it doesn't work right, and they're like banging their head against the wall, and it turns out, well, the manufacturing process was bad. Because these things aren't, they're not commercial in the sense that Apple and Google are commercializing them. These are hobby kits, so Some of them go in runs of a couple hundred or a couple thousand. The other ones, might be built one by one, depending on which brand or platform you're going with. So it's totally likely that after waiting 3 months and paying your $174, because when I got this it was new and so I was back ordered. It's totally likely that you're going to get a board that something's wrong with it. And their validation image is really nice because I think it means you're less likely to get a bad board because they can run the validation image on it in like 2 minutes before they QA it. And so if you have a problem with it, contact the manufacturer, tell them, they'll get you a new board because it's totally possible that it's just, it was a bad run or something. And let's see. So I'm not going to be able to go through this whole process because we're totally out of time. But the site here is pretty good. There's also omappedia.org and then Linaro and Ubuntu. And between those 4 sites, you can get the pieces that you need. To put this thing together, I actually have the Ubuntu image that I want to use on here. So I'm just going to try to get a power cord that's going to fit real quick. And let's see if this fits. If it fits, it ships. Sweet. That's right. So I'm going to at least try to do some video on here. And I was going to have this demo where I showed what the pizza boxes were for. So I'll go ahead and do that anyway. Because this isn't just about... I'm talking about ARM, but I'm also talking about just awesome hackery. So the sound's actually coming from the pizza boxes. But this is just... But like when you get into the idea of like prototyping stuff and building your own crap, then speakers like this are really cool even though they have nothing to do with ARM, and plugging into like one of these things would make it really interesting. So I was kind of hoping to do the demo with this, but I don't think I'll have enough time to actually get an audio player up and running on it. But I will try to plug it into HDMI.
No, you have 15 minutes.
Oh, I do have 15 minutes? Wait, what?
Our presentation. It was supposed to start at 11:15, so you have till 12:15.
Oh, sweet. Okay, so I was wrong about the time twice. Why can't we just do on-hour stuff? Yeah, because when it ended at the time, the last one ended at the time that it did, I thought that there was a half hour in between, but there was only 15 minutes in between because maybe he went 15 minutes over, maybe we just have 15 minutes. Yeah, you want to try to plug this thing in? And then I'll see if I can get this to reach over here. I don't have an HDMI extender, unfortunately. But as always, for the best out-of-box experience, use Ubuntu. Not as many Snickers as I thought. Okay, so is that plugged in?
Yeah.
Okay, then it should start booting, if we're lucky.
Do we need to press the HDMI button again?
Maybe. Oh, sweet. And so the way that you interface with this is, so this is USB serial cable. This one's made by FTDI. If you're using Linux or Mac, this is the one to go with. Most of the serial USB adapters that I found are by FTDI, but there's another one. It works with Windows, but it doesn't work with Linux, and this one doesn't work with Windows 7 very well. Oh yeah. So no problem, right? But for Mac, you just download a driver. It installs as a PKG, very simple. And then I think you might have to reboot to get it to recognize it. And then in Linux, like most things, it just works. At least most things that involve development. And maybe I've got a USB extender in here. And I do. And it's one of those lovely Apple ones that has that notch in it so it doesn't work with anything else. Okay. And so you can see that it boots up. Let's see, does there happen to be a USB keyboard laying around? Because it would be really cool if I could log into it, right? And be even, let's see. Cool in the gang. If I still had the validation image, I'd boot up with that, but then you'd basically hear a sound like what you just did. Okay. But what I'm going to try to do is serial in, and I'll let me put this back up on the screen, because you see that the HDMI works, and that's cool enough for the example purposes. And then, so the program that I use to get into this stuff is Minicom. Anybody used Minicom before? Okay. You can also use Screen, maybe Tmux. Is Tmux a serial thing too? I know I've heard people talk about Tmux just at the conference here, that it's something kind of like Screen. I don't know. Okay. And then there's other things that you can use as well. So I'm going to put this up on the, if I can figure out how to, this way. Okay, cool. Okay, so on Mac it shows up as like tty.usb, I think.
Capital U.
Oh, is capital U?
That's so. Maybe no dot.
Or, oh, there it is. No, on Mac it's different every time because it shows up with the serial number of the chip. So like every time you switch, no, it shows up, is it the serial number? No, it's the serial number of this thing. So like if I were to switch what I'm connected to now, oh no, wait.
No, it's vendor product data.
No, it's
for
the
the
USB.
No, okay, it's this chip. The thing is, the other boards, some of the other boards, they have the USB chip on here. So the serial to USB adapter is built in on the board. Like this one, it's this guy right here that says FTDI. So like one of these is an on-the-go port, which is where you can, so you can configure the Linux kernel to plug this guy in and he'll act like a hard drive just like your phone does. And then this guy is the console port. So they're a little bit different that way. But then let's see. Hopefully this will work. Oops. So sudo minicom-s. Probably typed that wrong. And I think almost all of them are the same way in that you have to turn hardware and software flow control off, the bit rate to the highest it can go, and then it looks like the last serial device I used may have been this one, but I'll delete it and repaste it just in case. Oops. /dev/tty. And then I'll go ahead and save that as Panda and exit. And if I, oh, well that's terrible. So I would get your normal prompt that you get to be able to log in as root and stuff. However, Ubuntu, contrary to my previous statement, which I will retract now, for some reason turns off the serial port as a console by default. So it would be so awesome if I could get in here and show you that I've got Node.js installed and show you that I'll show you a site that I run on here sometimes. Let me, where'd my Chrome go? Okay. So towards the end of the media server, there's this thing. Oh, by the way, we're hiring at Spotter RF, and I didn't talk a whole lot about us, but we're a cool technology company, and we do stuff with radar. Did I mention that at all at the beginning? No. And then Eric Jacobs here, he works with us. Really cool guy. Very good sysadmin, network administrator, does all the things, and teaches us about internet memes on a daily basis. But this is a little app that we wrote for one reason or another, and then like we kind of did it at work, and then like one of the employees and I, we took it home for a weekend project, and so like this is in Node.js, and this will run on ARM, and so this is kind of a step closer to the idea of a media box. You can just take a file and then drop it in, and I'll talk more about this kind of stuff tomorrow at the HTML5 and JavaScript presentation. If my mouse would stop being counterintuitive, I could actually grab stuff on the screen here because I didn't have so many windows open. Okay, top secret, confidential, proprietary. That's the file I want. So I just drag it in, it uploads it, and I can download it again. Anyway, so that like just this web server thing runs on these devices just fine. That's the point I was trying to get across. So you can do really cool and really fun stuff.
Which web server are you running on there?
So Node.js.
Oh, just Node itself is the web server.
Yeah, and Nginx will run on here as well. And if you want to do stuff that's hardcore, then I totally would recommend Nginx. I totally wouldn't recommend Apache. It blows my mind when people talk to me and they're like, oh yeah, we didn't want to put a web server in our product because that's just, well, that's overhead. We don't have enough RAM for that. And I'm thinking, you don't have enough RAM to parse 4 new lines, and what? So apparently Apache and the Java solution for Apache are like the most monstrous, humongous things ever, and they consume lots of RAM and lots of threads. But like Node.js and Nginx, they're like, I think Nginx is 2 megabytes and Node.js is 8. So it's like way well suited for something small and embedded, if depending, because like I said, as I've played with this as a media server, when I/O gets really heavy, Node kind of craps out. So.
Does that Mac have a SD card reader in it? I'm not familiar with it.
The MacBook Air does.
Could you take the one from the Panda, then put it into your Mac, and then edit the things so you can get serial over it?
Yeah, edit in tab.
Well, the thing is, I haven't. If I knew how to do that, I would have already done it. I'm not sure what the configuration is.
It's not just in a tab on recent Ubuntu's.
Oh.
Yeah.
Plus max mount XT.
Well, but I've got a VM,
Oh.
so no problem. And I even have a little.
In theory, yes.
In theory, yes. Experimenting now, probably not.
Yeah. So this was cooler than I originally thought it would be, but not as cool as I hoped that it could have been. Anyway, more questions? Chat. Who's doing stuff with ARM right now? What are you guys doing? If you know.
Well, I mean, all the devices at work are ARM devices.
So what are you doing?
Control 4, we do home automation.
Oh yeah, sweet. Way awesome.
So I don't know if you're familiar with the Motorola line of products, but they're running Ubuntu on their laptops. So you get Android and Windows, and then if you hack it, you can get a full Ubuntu 904 or 1010, depending on your flavor. So I've been experimenting a lot with cross-compiling, and I got QEMU compiled. Took 3.5 hours.
Yeah.
For a dual-core phone and a gig of RAM, it's not bad. As an ARM platform. What they do for cross-compiling is they have you use rootstock with one file from code sorcery. So you're running QEMU in a VM or your host environment with a CH root, so that your parent kernel and everything is ARM, so you don't have to set up any tool chains. You just use GCC straight.
Yeah, and that's how Linaro works, I think. Because I've noticed when it installs the Linaro toolchain on Ubuntu, it does like QEMU, and then like Linaro is so cool because they have so many packages for the different boards. You basically just give a command line parameter like -- BeagleBoard, and you tell it what system software you want, and it'll pull down the right kernel modules. Kernels are a little bit different with the embedded stuff because like the driver is for the motherboard as a whole. But yeah, and they use QEMU and some other stuff.
You know, I'm using Lego Mindstorms.
Oh, Mindstorms?
Yeah.
Is that ARM? Oh, yeah, Mindstorms is way cool. If you haven't played with that, I don't know if they're still doing it, but Lego had a thing with, what's it called, App Inventor? So Google had this graphical programming language, and it was called App Inventor. It's for Android. And I've actually played with it at the Utah Google Technology Group when they had a night sponsored by Lego. And so you can like select Bluetooth and then select Bluetooth turns on and then select like connect to remote. And so you just drag and drop these actions. And that is set up to work with Lego Mindstorms. I think it either went to the Apache Graveyard or got donated to MIT or something like that. Yeah, where all the good projects go to die. I mean the Apache Foundation. One of my alphabet letters off there. And you said you're...
Tablets.
Yeah? Cool beans. So who's looking to get into ARM? Everybody in this room, maybe? Just a few people? All right. So what are the rest of you here for? Good times? All right. So what do you want to do with it? Those of you that are...
I think it would be neat as an experiment to run StarCraft on my phone. But
Oh, heck yeah.
that's me.
Oh, yeah, and emulator support for ARM is really good. So if you want to do like Nintendo, Super Nintendo, anything like when it comes to games, you can basically get all like 2,000 arcade games ever. Actually, on ThinkGeek, they sell something that's it's the size of a Nintendo controller, the old school Nintendo controller, and it's got like every arcade game ever on it, and it's an ARM-based system. And there's instructions online for how to build your own. In fact, at the, well, I don't think they use ARM, but at the Hackerspace, the Transistor, they have an arcade that they've built like everything, manufactured it themselves, and they've got one of the Linux distributions that's like a arcade game Linux distribution. But those are pretty easy to get on the little ARM controllers too.
I teach a computer architecture. And one of the things we've been doing is using we call it LC3. It's really a made-up educational.
Yeah, I've actually programmed with that.
ISA. Anyway, one of the comments my students always make in the end of the class is, why don't we learn on something that's real, like ARM or MIPS. You know of anything like that? Anybody that uses actually? I mean, do you actually do assembly language on your ARM, or you just mostly do?
So,
CC, stuff like that.
I'm personally not cool enough for the really low-level stuff. So I stick in the upper level, but if you wanted to look at a large project that utilizes some assembly for ARM, V8, all of their code is optimized for the architecture. So V8's ARM code is like, there's tons of assembly in the V8 stuff. But I personally don't program in it. You can, and Arduino now runs on ARM too, and they have, I think they have an Arduino MIPS and Arduino ARM and like FPGA something or other. There's a comment over here?
Well, just the whole point was with the Raspberry Pi, and we kind of pushed some things. The nicety about ARM over teaching any other system is you don't have the BIOS, you don't have the weird boot process with Intel, with setting the right bit process. It is literally, I'll grab the first thing that's done on your chip, on your SD card, and start to run it. And so you can actually go all the way from, you have them write a single image that does nothing but turn an LED on one of your GPIOs without even having a Linux operating system, and then from there build up. And it's a fantastic system to teach somebody how an operating system goes from a bit to physical representation and to kind of grow.
Has anybody actually got a Raspberry Pi?
They started shipping like this month or maybe next month.
They shipped last month, and then the next one for those people that pre-purchased on the day it came out, you get it in June.
Yeah.
So I'm hoping for my June one.
Yeah, so I bought it the day after it came out, and mine ships on June 18th.
Yeah.
Well, they said that they've gone through the QA process and everything's good, so it's just ramping up production at this point. They've got like somewhere close to 100,000 orders. They said that they're producing 100,000 of them right now.
250,000 right now. That's the total of it, and they've actually taken off pre-orders off of the new work in Element 14? Like, you're back on a waiting list.
Yeah, so I ordered through Element 14, and they sent me an email that said that they're producing 100,000. So I would assume that the other ones have got like volume. So right before we do the clapping, if I could just take a minute, just a quick minute while we're already over time, just to explain why I'm dressed up in a cowboy suit, and that's because I wanted to. It's fun. And the other thing, I mean, there's no ladies here to impress, but I look sexy in this, and I know it. The other thing is I did want to give a plug for Spot RF. We're hiring. Our CEO is a really kind, generous guy. He's also very business savvy. I really appreciate and value him, and like the work that he does and his morals and values with the company. And then I am not very business oriented at all. You know, he's pretty like, you know, professional, and I'm kind of like, whatever. I'm dressed up in a cowboy suit, right? But we're a fun company. We produce a radar that the purpose of it is to help save lives. It's a tracking system. If you're like a low-level guy and you're looking for work, we've got like a bunch of FPGAs and DSPs and stuff like actually in the box that do all the like the hard algorithms and everything. And so yeah, we send signals back and forth. We get range and angle data, and so we tell where something is, like a moving object, such as a person or a car or somebody crawling on the ground. It's for security purposes. Primarily, we sell to the military, as you can kind of guess from that poster there. And then, like in-house, we use like a lot of Node.js for like our debugging tools. We use a lot of HTML5 and JavaScript. Like all of our apps that interact with this that we ship are all HTML5 and JavaScript. So it's got an API on it, and it shows a tracking display with like real-time updating and stuff. And then like we do occasionally do fun, totally off-topic things like that drop share site I was just showing you. It started as a project at work. It moved home. It came back to work. It went back home and kind of developed that way. So. Anyways, we're fun and we're looking, so thanks.